All right, well, I hope that y'all are doing well. It's toward the end of the semester now. This is our final lecture. I'll remind you again at the end, but our course material will end with this particular lecture. Keep those emails coming to get the extra credit, and I hope that y'all are doing well. So we're going to be talking about renewable energy options now. We talked about some fossil fuels last lecture, and we're going to talk about some different energy options today. So there are three energy alternative sources that are very well developed, and we call these conventional alternatives because they're not fossil fuels, but they are a little easier to get lots of energy online as opposed to some other sources. So there's a couple of them that I want to talk about first. So the first is biomass, right? So, if we think of fossil fuels as energy that has been stored in plants captured by the sun hundreds of millions of years ago, it's like long ago material that died long ago. Biomass is recently dead material, right? So biomass provides about 10% of the world's energy, nuclear about 6%, and hydro about 2%. And nuclear energy and hydropower together account for about 1/3 of the world's electricity altogether. So nuclear and hydro are significant sources of energy. So again, biofuels derived from recently dead living material. And there's two ways we can go about producing biofuels. The first thing we can do is to grow crops that have a lot of sugar in them. Things like beets or corn, as shown in this picture here. And then we can ferment them to produce ethanol. And then that ethanol, you probably have all seen it on the gas pump. Ethanol can be added to gasoline, or used in other ways as well. The other thing we can do is we can grow plants that have lots of oil in them. And these oils can be used directly in a converted diesel engine. You might know some friends that have done this. You have to change the seals and do a couple things, and then diesel engines can run on vegetable oil. Or you can convert the vegetable oil into biodiesel, which then can be used in regular diesel engines. But instead of being derived from fossil fuels, it's derived from plants. So biofuel production is definitely on the rise, particularly in North America. We talked the other day about this idea that the amount of corn being grown has gone up, the price has gone up because it's not only just being grown for food anymore, it's being grown for biofuels. So, but you can see, right, from 2007 to 2013, we've just about doubled the amount of biofuel grown globally. All right, so what are the drawbacks of biomass energy? Well, if it's used in the developing world as wood for cooking and heating your home, there's the problem with indoor air pollution. Then it connects to deforestation, because if people are burning wood, then there's the temptation to cut down the trees and overharvest the timber. Now, if you're doing things through agriculture, like you're growing soybeans or corn, for instance, then we're going to have all the downsides of industrial ag, right? The use of fertilizers and pesticides, all that. And again, we're going to have to convert land to agriculture or into these plantation artificial forest looking things like the picture on the right, which are not going to have all the same ecosystem services as a natural forest would. So yeah, the other drawback, again, competition with food production. The more biofuels we grow, the less land we have devoted to growing food. And as we know, we're going to have to work on feeding our population as we get up to 10 million, as it may be at the end of the century. The other thing has to do with what's called carbon neutrality, right? So we want our energy production systems to not have a net increase in the amount of CO2 in the atmosphere. And so with fossil fuels, of course, those aren't carbon neutral because we're taking carbon from under the ground and burning it and putting it up in the air. Well, with biomass energy, if we're cutting down and burning or harvesting the biomass faster than it can grow, then in fact there's a net flow of CO2 into the atmosphere. But you can imagine if we're harvesting and burning the crops at the exact same rate as they're growing, then it'll be carbon neutral. So it just depends on how fast we use it, whether biomass is carbon neutral or not. All right, let's chat a little bit about nuclear power. So nuclear power is a whole different deal. So in 1938, the first nuclear reaction was created in the lab. So they bombarded these atoms with neutrons. The neutrons then hit the nuclei of the uranium atoms and split them into pieces, releasing more neutrons. And as you all know, incredible large amounts of energy were released when this happened. But there are two types of nuclear reactions. So fission is what I just showed you an example of, right? It's where neutrons are used to break the nucleus apart, and that releases a lot of energy. Now fusion is the opposite. Fusion is when you have multiple nuclei that come together to form a larger nucleus. We have not been able to do this in controlled conditions yet. Because nuclear fusion releases a lot more energy than nuclear fission, but it's a lot harder to do, and like I said, we haven't been able to. So when we talk about nuclear reactions, we're just talking about fission. That's basically that's the conversation right now. So the way that we typically generate electricity is by producing steam and then using that steam to turn a turbine. So in the case of a nuclear reaction, we have a uranium fuel assembly, and that is the fuel that creates this nuclear reaction. And then we have control rods, which we can use to control the rate of that reaction. They absorb the neutrons, and so they can slow the rate of reaction. Because it's a chain reaction, because as each nucleus breaks apart, it breaks into pieces, it releases more neutrons. Those neutrons hit other nuclei, which break apart, and etc. So we have one contained water circuit that is highly radioactive and gets really, really hot, this reactor core. Alright, so the water in there gets really, really hot, but it's enclosed in its own water circuit. But then it comes on over, slides over to the right to this heat exchanger, where it heats up the water in this second circuit to the point where it becomes steam. Alright, and the steam then comes through the pipe and turns out into a steam turbine, where it turns this turbine. There are magnets arranged around that, and as they spin around, they create a current of electrons, which sends electricity out to the grid. Then that steam comes down into a pipe into this condenser where there's cool water. Right? The water doesn't mix at all, but the pipe that the steam is in this cooler water, so it causes the steam to condense into liquid water. And then it comes on down to the bottom and goes back into the heat exchanger. And then the water in that condenser is connected to a lake or a cooling tower. So if you've ever seen those kind of characteristic big tower things in a nuclear reactor, those are the cooling towers. They don't have anything radioactive in them at all. They're just designed that way to maximize the potential to cool that water off. Alright, well, Chuck Norris is here to tell you about some nuclear power pros. This is where I'd ask you all to come up with these, but since I can't have a conversation with you, I'm just going to have to list them. So the advantages of nuclear power is a lot less environmental impact than fossil fuels. Because when you think about the fact that a third of all air pollution comes from coal power plants, then being able to reduce that is an amazing thing. And 15% of all greenhouse gases come from coal power plants. So again, from a carbon neutral perspective, nuclear energy is great. It's doing great, right? There's a little bit of energy that's required to mine the uranium and all those kinds of things, but in a big picture, it's very good. Also, there are folks that say, nuclear is great and all. Really, what it's beneficial for is for like a stopgap measure that we can get our energy from until we're able to get more of these other carbon-free renewable energy sources online, as we'll talk about in just a moment. All right, well, what about the nuclear power cons? Kevin is here to talk to us about that. Well, the waste from the fuel rods is radioactive waste that is very dangerous. It's very dangerous and it's difficult to store, and it takes thousands of years until it isn't dangerous anymore. So somehow we're going to have to store that for thousands of years. Have we ever done anything for thousands of years as a society? Definitely not. The other point is that there's a little bit of carbon that is used in the mining process, a lot less than fossil fuel combustion. And of course, the other piece is that these nuclear reactors always have the threat of a meltdown. It's very low, and proponents of nuclear power would tell you that it's perfectly safe, but there is at least a little bit of a risk involved. All right, well, what about hydropower? So hydropower is when we take advantage of the water cycle to generate electricity. So the water, of course, flows from higher elevation to lower elevation. So what we can do is build a dam across a river and create pressure, right? Hydraulic head. So the water depth builds up behind the dam. And then under pressure, that water shoots down through tunnels in the dam. And as it comes down through that tunnel, through that intake, it hits the powerhouse. And the powerhouse, it spins a turbine around. Those turbines then, as they spin, generate electricity, right? And then the water eventually comes on out on the other side. And those turbines generate electricity. So we're taking advantage of natural processes here with this hydroelectric power. So pros and cons of hydropower. It has an extremely high energy return on investment. That means for the amount of energy we put into generating hydropower, we get a lot of energy back. It has a very low carbon footprint. Almost no CO2 is released at all in the process here. The construction has some CO2. There's some concern about methane building up and the bottom of the reservoir, but generally pretty good. And it's renewable in the sense that as long as the water cycle keeps running, our dams are going to keep working. The main cons are the negative impacts on aquatic ecosystems. So it destroys habitat for aquatic species as well as terrestrial species, because when you build that reservoir behind the dam, it floods whatever else was behind it. And then it has also the impact of submerging cultural heritage as well. We like to build our cities and towns along the banks of rivers because it's a good water supply, the land is fertile, all those kinds of things. So when we come in and we dam these rivers, those are the kind of communities that unfortunately get submerged. So that's another downside of dams. And then, of course, the dams themselves are barriers to migratory fishes. So you might have heard the story that the Chinese sturgeon went extinct as a result of dam construction, unfortunately. So a little bit of a diversion. I thought I'd share with you a story that I was connected to when I was in Nepal in 2015 and 2016. In the U.S., we built most of our dams either right after World War II or, in fact, during World War II. There was a high demand for electricity, and so these hydroelectric dams were one of the ways that we produced that electricity. But other countries like Nepal haven't built many dams at all, and the majority of their rivers are free-flowing. And Nepal is really rich in hydroelectric potential because it has these really tall mountains and all this water running out of the mountains. And so if you did build dams on these rivers, it would really generate a lot of electricity. And they've built a couple. And in fact, Nepal gets about 85% of its electricity from hydro, which is pretty impressive. But I was part of a team that was going to try and see what the potential impacts of constructing a dam on Nepal's Karnali River would be. This is a river that doesn't have any dams at all. So it's just a beautiful part of the world. And so our goal was to visit some sites near where this dam is going to be constructed and see what the potential impacts on the aquatic community were going to be. So it was really a project. It was really a pleasure to be part of it. It was an amazing experience. And if you ever get a chance to travel to Nepal, please take it. It's an amazing. So Google Earth image of the river in red, and all these planned hydroelectric dams are those little orange triangles. There's a bunch of them. You see the one that says Upper Karnali Proposed Dam Site. That's the site on the river that we were trying to evaluate, kind of above and below it. Getting around is tricky in this part of the world. This is our Jeep driving along these roads very carefully. I try not to look out the window. You can just see the back of that van too. It's kind of cool. It's got this, or that Jeep. It says free Wi-Fi on the back, but there was no free Wi-Fi. It was purely decorative. This is kind of a sad picture. This is survey work done for where that dam's going to be constructed. And you can see in the upper center a pilot hole that's been dug there. That's how high the water level would be once the dam was constructed. And the water would rush through that hole and actually, interestingly enough, down through that mountain, downstream into the river. So they wouldn't even have to build a very big dam. This is our crew. The guy there to my right, actually I wrote a letter of recommendation for him, just got into Yale School of Forestry, so he's going to be going there soon, assuming that situations get back to normal in the near future. I found some cool stuff. These little pufferfish, this one on the upper left, they were living in this vegetation, and we're like, wow, what are those? Oh, they're pufferfish. You'd hold them in your hand, they'd puff up. And this crazy shrimp that I'm holding right there with these huge claws. They were crazy looking organisms out there. So when you go up a little higher into the river, you get into these rapids. These are a couple students from Kathmandu University that came with us to do the work using an electrofisher. They did an awesome job, and they have really cool hats. And some of the fish we catch here are adapted to live in high flow velocity habitats. So the catfish on the bottom has those grooves on its ventral surface, which it uses as a suction cup to latch onto rocks. And then the fish just above that also has a suction cup below its jaw that it uses to attach to rocks. So you kind of see the morphological adaptations of the fish to live in this part of the river. Clearly, this kind of habitat, this kind of rapid habitat would go away if you created a dam. Here's me looking really cool in this bridge overlooking a village. And this is kind of sad because when this dam is built, if it is, this village would be underwater, so everybody would have to move. Fishing is a big part of the economy in these areas, so these folks are getting ready to float a net out into the river to catch fish. But if this dam does go in, nobody knows how it's going to affect aquatic biodiversity. So these fishes, the one on the top is the genus Schizothorax. It's called a snow trout, although it doesn't live in the snow and it's not a trout, it's a minnow. The one on the bottom is called Masir. It's actually an important sport fish. But we have no idea how these fish are going to be affected if that dam goes in, because people haven't studied their migration patterns at all. This is us hanging out. This is our team. We would stop by these shops in the marketplace for a cup of chai. You can see in the foreground there, and just kind of hang out. I'm rocking my UNC Asheville shirt right there. Okay, so back to the renewable energy story. So we also have what are called new renewable energy options, and these are sources that we don't currently get a lot of our energy from, but they're growing fast, really fast. And those are solar and wind energy. And so I think it's important to realize just how fast renewable energy is growing. if we look at the total amount that was installed from 2000 to 2014, it more than doubled, right? Now, a fair amount of that have been hydropower, as you can see, but wind energy coming up fast, solar energy coming up fast. So we're getting a lot of renewable energy coming online very quickly these days. If you look at how much is added, again, we're adding, in 2014, we were adding 6 times as much new renewable energy to the grid each year, 6 times as much as we were in 2002. So just amazing how fast this growth is happening. And you can see wind energy was a big piece of that, but recently solar has been what is really being added in pretty high amounts. So you're going to see a lot of graphs like this. The main story with renewable energy is that it's growing fast. It doesn't give us as much as we'd like to yet, just because we haven't invested in it heavily enough. But it's growing fast based on market demand. It was wind before, solar now. So if you look at wind energy from 2000 to 2012, it's grown by over a factor of 6 as far as the world wind capacity. So much more wind energy than previously. If you look at solar, it's even more dramatic. You can see it wasn't really until 2009, 2010 that solar really started growing. And so in 2012, right, there was like 30 times as much global capacity in solar as there was just in 2004. So amazingly high growth in these renewables. So let's talk a little more about how solar works. So you can use passive solar heating, for instance. Today was a sunny day here in Nashville, so I was drying some towels outside. We find we save about $20 a month when we can dry stuff outside as opposed to in our dryer. So you can just put stuff out to dry in the sun. These black tanks are used to heat water. In a lot of the global south, when we were in Nepal, we saw a lot of tanks like this. They'd warm up in the sun, and then you could get hot water. By late in the afternoon, the water's naturally heated. You can use it for a shower. That's what we did when we were in Nepal. Now, down below shows the influence of solar energy and its relation to green building. So, in the winter, when you want your houses to be warm, that is also the time when the sun is lower in the sky in the northern hemisphere. So if we have a big south-facing window, it lets all that sun come in and warm our home, right? We can have our own little greenhouse effect going on in our house. But then we have this overhanging roof, and what that does is that in the summer, when the sun is high and we don't want it to be warming our house anymore, it doesn't, because we've got this long overhanging roof going on there. So we can really use passive solar to cut down on energy bills and reduce the amount of energy required to heat our homes. But then we can actively concentrate the sun's rays as well. So you can do a water system. So you can have a solar collector box that collects the sun's energy, and then you have pipes running back and forth in there full of some kind of liquid. Often this is oil, because oil can get hotter than water, of course, without boiling. And you've got a pump that moves this oil through the system, and then the oil goes into a heat exchange box that could be full of oil or water. And then that exchanges the heat from this heated oil into the other circuit that has water in it. And so that water is able to circulate directly into a storage tank, and it's essentially a hot water heater, right? So you can concentrate the sun's energy without doing anything technologically very advanced to concentrate it. So you can also generate electricity this way. You'll see these parabolic mirrors that concentrate the rays of the sun onto a tube in the middle, and that tube is filled with oil, which heats up. And then the way that we generally produce electricity, again, is by boiling water, which then gets turned into steam and can turn a turbine to generate electricity. So a solar thermal electric generation system is something that uses the sun's rays the heat of the sun's rays to heat something like oil and generate electricity that way by turning water into steam. You also have these things called power towers. This is a picture of one out west, where in the center of this circle there's a big block of molten salt, well, salt in this case, and it gets heated to such a high temperature that it becomes a liquid. And that stores a ton of energy. So then that energy can then be used again to turn water into steam, which can turn a turbine and generate electricity. So in this diagram here, all those mirrors are focused on the top of that tower to superheat that salt. But the other thing you can do is to use photovoltaic solar cells to convert the sun's energy directly into electricity by creating a flow of electrons. And so y'all may have studied in physics the wave-particle duality of light. And so light can be conceptualized as a flow of photons, a flow of these little packets of energy, right? And so when those packets of energy hit these photovoltaic solar cells, they excite the electrons, and these solar cells are constructed with materials that allow those electrons to move across the surface, and that creates, of course, a flow of electrons. And that's what electricity is a flow of electrons. And so these photovoltaic solar cells don't rely on the energy of the sun at all. Don't rely on the heat of the sun at all. They rely on the energy as expressed in these little photon packets of energy that excite electrons and create that electric current. So for a long time, people were saying that solar photovoltaic cells are expensive, and generating electricity with them is very expensive. Well, there's something called the Swanson effect, and that describes the dramatic rate at which the cost of generating electricity with photovoltaic cells is dropping. Okay, so it really has to do with the price of these photovoltaic cells. So if we look at in 1977, the price to generate 1 watt of electricity from these solar cells was about $76. All right, now you look in 2013, it's 74 cents. Right? So it now costs 1/100th what it cost in 77. So and now it's even less. So it's incredible how inexpensive these photovoltaic cells are getting. It's just technological, and this is without a whole lot of government investment and incentives. This has really been happening, kind of driven by the market. There have been, during the Obama administration, there were some economic incentives, but not as much as we give to the fossil fuel industry. To give you an idea of the volume of energy that's held in the sun, the sunshine that falls on Texas in 1 month contains more energy than all the oil that has ever been pumped in this state. So just think about that for a while. This amazing source of energy we have to tap into. So if we were to power everything we do on the planet with solar energy, this is how much of the Earth's surface we would have to use, right? So as you can see, it's not a whole lot of the Earth's surface. So basically, each of these little squares, if we were to convert them into solar energy, that would be all the energy that we would need on the planet. We wouldn't need a drop of crude oil. We wouldn't need a pound of coal. We wouldn't need any of that. So you just kind of look at where we would have to locate these to be able to produce everything that the planet needs, and so there you go, right? So solar energy, really an incredibly large amount of potential. And so the solar intensity, the amount of energy available per square meter per day, is certainly highest in the southwestern U.S. And so that's why it would make more sense to site our solar farms there. Okay, wind energy, again, on the other hand, this is something that has grown quite a bit. So from the 1990s to the 2010s, it was the fastest growing source of energy, cost competitive with many conventional forms of energy. So when we were living in Texas, you could choose how much of your energy you wanted to get from wind, and it costs essentially the same amount as coal. It's really developed well out in Texas. So if we look at where the average annual wind speed is, we see, perhaps not surprisingly, right through the central and midwestern United States, extremely high rates of wind. And so that is where we like to site those wind turbines, right? So we can really, the great thing about wind turbines is they don't take up a whole lot of area. It's just the base of the turbine itself. It doesn't, you can site them in ranches and that kind of thing. The land can have other uses as well, in addition to producing electricity. All right, so we can arrange all these different types of energy according to what we call the energy return on investment. In other words, how much energy do you get relative to how much you have to put in to generate it? And when we do that, hydropower turns out to be the highest, right? Because we just don't have to do a whole lot. Now, coal and oil and gas are relatively high as well. Then we have wind power, nuclear, coal, photovoltaic, solar, right? But then things like oil sands are quite low. Natural gas is quite low. Shale oil quite low. Yeah, but hydro is definitely way up there. So this is the energy return on investment. Well, then we look at the carbon intensity. This piece is not only looking at how much energy does it take to produce the energy, but how much carbon is required to produce that energy. When we look at that, not surprisingly, right, it's kind of the fossil fuels and then everything else. So if we're trying to find a way to get our energy from sources that don't put a heck of a lot more carbon into the atmosphere, really any way we go besides natural gas, oil and coal is where we want to be. I'd also point out that natural gas is a lot better than coal, so the increase in natural gas development lately has been a good thing. But again, you look at all of these renewable energy sources right there for us to use. So now the other part of the piece, you often hear folks say, oh, well, we can't switch over to renewable energy because of all the jobs that are in fossil fuels. Well, in fact, there are 3 times as many people working in clean energy as in fossil fuels in America right now. So switching over to renewable energy would in fact create jobs rather than losing jobs. If you wonder where those jobs are, there's a lot in solar photovoltaic right now. So that's really the fastest growing. There were globally there were 11 million people employed by the renewable energy sector. I think these are data from what year are these from? 2018 maybe. Whereas in 2017 there were only 9 million employed. So it's growing quite rapidly. Right, liquid biofuels, hydro, wind energy, a lot of people employed. So from an employment perspective as well, it would behoove us to switch over to renewables as soon as we can. All right, well that's going to wrap up the lecture content for our course. All of the material for the final exam will only go up through this lecture. I hope y'all have enjoyed this course. I really enjoyed getting to know y'all. Sorry things got changed up the way that they did with COVID, but what are you going to do, right? So I'll be sending out an email over the weekend or on Monday about our final exam and how all of that is going to look. But just a reminder, you can still email me your article summaries. If you email me with 2 of those, then you'll get 10 points extra credit, and you can do that up to 3 times. So I hope you all are well, and I look forward to talking to you soon, one way or another.